Okay, today we're going to be looking at section 9.7, which deals with linear, quadratic, and exponential models. So we're going to be trying to decide which model would fit the data best. So hopefully by the end of this section you can say I can choose a linear, quadratic, or exponential model for a set of data. So just quick reminders, review what linear, quadratic, and exponential functions look like. So linear is the first thing that we looked at this year, and that was simply the points that come out to be looking like a straight line. The third one is the exponential. That was the next one we started with. Either starts small and grows quickly, or the other way it could look like this as well. This would have been a growth, if you remember talking about exponential growth. This one we would have said was an exponential decay. And then this is the middle one is our quadratics, which we have been studying this chapter. Okay, so what kinds of things might you do today? You might have to graph points. So like for instance, 0.5. So if I graph this data onto this graph, 0 and a 0.25 would be like here. A 1 and a 0.75 would be like here. A 1.5 and a 1.3 would be like here. And then a 2 and a 2.25. And then a 2.5 and a 3.9. And then a 3 and a 6.75. So we're looking at this. So just by looking at this and looking back to what we had to choose from, I think it's pretty easy to say that this would be an exponential. Okay, if I look at the next one, I've got a 0.5, 0.5. So that would be like right here. If I had a 1 and a 3, that would be here. If I had a 1.5 and a 4.5, that would be here. If I had a 2 and a 5, that would be here. If I had a 2.5 and a 4.5, that would be here. If I had a 3.5 and a 0.5, that would be like right here. And I think this we can kind of see as that general shape of a quadratic, something like this. Okay, so this one would be a quadratic. Hopefully I graphed all those points right. The next one, if I've got a 1 and a 1.5, I've got a 1.5 and a 1.75, I got a 2 and a 2, I got a 2 and a 2.5 and a 2.25. If I've got a 3 and a 2.5, I've got a 4 and a 3. So I think we can see there that that is very linear. Okay, so what happens if we're looking at a table? Well, here's what's going to happen. If we're looking at a linear function, so here's our function that we had, and these are the table of values that would have been generated from that. We can see that our x's over here are all increasing by a 1, and then our y's are all decreasing by a -2. Okay? That's for a linear. So we say our first difference is constant. So our first difference is constant on linear. Okay, if we look at a quadratic, so here's our quadratic. We can see that here, for instance, if I follow this table down, it increased, or excuse me, it went down by 3, then down by 1, then down by, or up by 1, then up by 3. So these differences, our first difference, is not the same. So if we're looking at a quadratic, our first difference will not be consistent. Okay, but then if we look at the next one, we went from a -3 to a -1, that's an increase of 2. I went from a -1 to a +1, that's an increase of 2. And from a 1 to a 3, that's an increase of 2. So here our second difference is the same for a quadratic. Okay, so if we look at the first difference is the same, it's linear. If we look at the second difference and that's the same, then we have a quadratic. For an exponential, if we were to look at the values here, now it's increasing by a constant rate. For instance, from here to here, we are showing that that's timesing by a 3. From here to here, we multiply by 3. From here to here, we multiply by 3. And from here to here, we multiply by 3. So what we have there is an exponential. Okay, so the other thing you're going to be looking at, you're going to be looking at a table of values and trying to determine just from your table of values what kind it's going to be. So if I look from here to here, I can see that if I look down at some of these other ones, it's a little easier to see first, and I can see from 5 to 25, I multiplied by a 5. From a 1 to a 5, I multiplied by a 5. 1/5 to a 1, that's a multiplying by 5. 1/25 to 1/5, that's a multiplying by 5. So I can see here that we have a common ratio, I would say. So here we have an exponential. Okay, for this one, I go up by 3. I go up by 3. So our first difference is all 3. So we'd say here that this is a linear. And just so you know, these 3's, that represents our slope on the linear. Okay, and now on this one, I went down 2, I went down 6, I went down 10, I went down, that would be 14. Okay, and then if I look at my second difference, so my first difference was not the same. My second difference, I go down 4, I go down 4, I go down 4. So my second difference, the second difference is constant. So this right here is a quadratic. Okay, so that's what you're going to be looking at on today's homework. You're going to be looking at trying to determine what type of model would fit it best. Okay, so hopefully you can make sense of that. If you can't, make sure you come with some questions tomorrow. That is a wrap.